Hello students, so today we will start with JEE Advanced 2025 Physics Paper 2 Analysis. Okay, so paper 2 was relatively hard, or you can say relatively lengthier than the paper 1. Okay, paper 1 was very easy. Here in this, some of the questions are, if you go with the easy trick, it will be easier, but if you go with general method, it will be lengthier. Okay, we will gonna see, and one question is little bit controversial also. We will see here. Okay, so first section we have +3 -1 single correct. See this. So first question we have temperature difference can generate EMF in some of materials. Let S be the EMF produced per unit temperature difference between that. So S he is defining as one quantity, which is EMF that we can represent. If you are going with the dimension only, we can directly take the dimensions, right? This is the way you have told. And then sigma. Sigma is electrical conductivity. So here we know that resistance is equals to V by I, okay, and resistance is what? L by sigma A, right? Resistivity 1 by conductivity, okay. This is in terms of electrical conductivity, right? And then he is saying thermal conductivity also is using. So thermal conductivity K, okay. So K also is using. So for that we will use the power. Power is equals to, I can say Ka. Delta T comes, so T by X length only, right? From here sigma came how much? From here multiply area this side, length this side, so VA by IL, and from here K came what? PX by AT, okay. T is the temperature, okay. Now he is defining a quantity Z equals to S square sigma by K, fine, and dimension he is asking. So Z is nothing but S square sigma by K. So S square means V square by T square into sigma, I can say VA by IL into K is in divide, right? So this will come AT by PX. Okay, P is the power, right? If you see here, power, okay. So sigma, when we are writing, I will go this side, na? Sigma this side, so sigma equals to, multiply that side, Li by VAV, right? That's what I thought. Li by AV, correct? So if we see here, now, AV, na? AV. So now if we see here, we can say length cancel out, power what? 1 voltage, V into I is power, right? So power cancel out with V and I, okay, and one more V that was cancel out with this, area got cancel out with this, okay. So you have T and one power got cancel out, this is 1 by T only, okay. Here if you understand, voltage into current, it is power, so power got cancel out, 1 by T. So this is 1 by T only, means Kelvin inverse, Kelvin to the power -1, others are 0. So if we see, this is option B is your answer, okay. I hope understood. Option B is your answer. Option B, answer. Got it? Easier. Why I thought like that? Because as he is defining EMF upon temperature, so resistance also I have to think in terms of voltage and something like that only, right? And then I have to go from here, thermal conductivity, what can I think? Power, voltage, power, current related. So by that I thought that power formula can be used, okay. That's how I connected. I tried to connect it, okay. Question number 2, okay. So second question he is saying, diagram, this is the diagram. So what he is saying is, there is a material thermal K equal to given as 5, okay. And he is saying that at R radius from the center, at R distance, there is a plate, okay. So this plate you can observe, plate is placed like this. This is the top view. This is the top view, figure 2, okay. So from here, like this is the plate. And then he is saying in the question that outer radius is 2R and inner radius is √2R, okay, are kept as shown in the figure 1. The charge on the inner cylinder is Q, okay, and the outer cylinder is grounded. The annular ring annular region between the cylinder is filled with a material of dielectric constant K is equal to 5, as we said. So K equal to 5 is there. So with epsilon naught we will multiply epsilon r as 5. Okay. Consider an imaginary plane of the same length L at a distance r in the common axis of cylinder. This plane parallel to the axis of the cylinders. The cross section view of this arrangement is shown as figure 2. So figure 2 he shown the upper view. Okay. Now ignoring edge effect, the flux of the electric field through the plane is okay. So he is asking the flux in this. Understand this question. This question to do, we have 3 methods. Okay. I will tell one by one, and last explain I will do. Okay. This is inner. Okay. This is outer. This plane he is talking about, right? Okay. First of all, outside connected. Okay. So inner one you have plus Q. So here inside minus Q and this side 0. Okay. So this side 0 means here electric field 0 outside, inside also electric field 0. Here there will be electric field. Okay. So electric field is available here only. So means I can say through this line electric field will not cross. So there is no flux in this. In this no flux. Outer one no flux. Okay. So flux is in this part only. Okay. Now one thing what you can do is flux is in this part only. So from the center, this point I can connect and this point I can connect. Okay. As I know, this is R. Okay. This is root 2R, this is 2R. So you find out the angle. This comes 45. This is root 2R, na? This. So this angle will come 45. This total angle will come 60. Okay. So this angle is 15 degree here in the middle. Okay. If this angle is 15, so according to that you find out the charge enclosed here in this total region, this region. Okay. So by that charge you can answer. So there will be plus Q. So there will be a effect of we can say K equal to 5. Okay. So that effect you will consider, then only answer will come correct. So this enclosed charge in the 15 degree total is Q. So accordingly you answer. Okay. But K equal to 5 that you have to consider, then only answer will come correct. Okay. Similarly the same thing will be here also. Here there will be charge enclosed. Okay. So 2 you have to multiply. That's it. Q inside by epsilon naught you can answer by that. Another method is that, as we know, that electric field is this direction, like this, not from here, actually from here only, right? So in this region, you can say, you can consider a part, okay, and electric field is this direction, this is theta, okay? So electric field component E cos theta you can take, okay? And then you can write down the flux from this particular angle, which is 60 degree, means pi by 3. Integration will happen till pi by 4 and multiply by 2, whatever flux you will write down. Okay. These are the 2 methods. These are little bit, both methods are little bit lengthier. Okay. If you go with method 1 and method 2. Now see the shorter one. What we have is, let me draw a new diagram only. What we have, bigger sphere. Okay, and then inside it have a smaller sphere. Okay, fine. Like this it is. Okay. Drawing bigger diagram so that you can understand. Here if I draw, this is the surface. Okay. So I am considering an enclosed surface, as we know already. Okay. I am considering an enclosed surface like this. Through this line, like this we will go. And through this again, like this and like this. Okay. Like this. You can go straight also, that's same thing. Okay. You can go straight also. Now in this, if we mark point number what, A, B, C, D, let's mark A, B, C and D. Okay. A, B, C, D, if you consider the total flux, right? So if we know electric field is not here, so it will not cross. Okay. Electric field is not there, so it will not cross. Okay. So here there is no flux, right? The flux will cross through this region and this region. So if I want to write down flux, okay, which is nothing but Q inside by epsilon naught, okay, epsilon r also we will multiply, so there is a k also, okay, you can say epsilon r, so that we will take care of later on, okay. This is the q inside by epsilon naught. This formula we know in the closed loop, right? So this we are considering as closed loop. So I have to just find out the q inside. So as I know, there is a, in inner surface there is a plus q, right? On inner surface there is a plus q distributed in 360 angle, and on outer surface there is a minus q distributed in 360 angle. So if I find out q on this region C to D only and q on this A to B, then I will get the q inside, okay. That how we will find out, as we know already that how much is this angle. If I know this is r and this is root 2r, so this is 45, so this is also 45, right? So total angle is 90. So flux, what we can say, what we q inside. So here in this region q will be how much? I can say in 360 degree total is the plus q, right? So in 90 degree how much it will be? Q by 4, right? This is the charge, okay. And if you think about the outer one, so let me draw that also. Use this pen or this pen only, okay. Outer one, if you think, then this angle is total is 60 degree, right? This angle is 60, right? Total angle. So 60 above and 60 below, total region will come, right? Total distribution is minus q, right? So in this will be how much? So if I say 360 degree, the charge distributed is minus q. So how much it will be in the 120 degree? I can say in 120 degree, this will, you can divide by 3, so minus q by 3, okay. This is the charge. So by this I see the q inside or surface is how much? Q by 4 minus q by 3, that is minus q by 12, minus q by 12, okay. This is your q inside. Now flux, as I said already, that flux you know already from this surface and this surface will only cross, okay, you already know. If you consider a surface like this, still you know that through this surface there is no flux, through this surface there is no flux, okay. This only, that only we need also, right? As I explained, through this surface there is no flux, through this surface flux, this surface no flux, D to C no flux, C to B there is a flux, and B to below there is no flux. So same answer that I want, this Gaussian surface is also giving me the same answer. So I will go with this. So flux, I will write down q inside, that is q by 12, okay, divided by epsilon naught into epsilon r, that is 5, okay. So 12, 5, 60, q by 60 epsilon naught. This is your answer. So q by 60 epsilon naught is your final answer, okay. So 3 methods are there. Integration you can do. That kind of questions are also there, but I would recommend go with the Gaussian surface. It will be faster, okay. Without any mistake you will be able to do it, okay. Then next question. Next question, this question is actually notes question. In notes we do it like this. Even we did this question with 3 springs also, okay. So what he is saying is, he attached the below part and here he attached a spring, here he attached a spring. So if you move this, it will oscillate like this, okay. It will oscillate like this, okay, both places. We did it like this. If I tell you how we did it in notes, so it was something like this, that in notes it was like this. One spring here with different spring constants and one spring here like this. Different spring constant, like these questions we have done in the notes in SHM only, okay. So how we will do here, see, basic standard question this is. So you have a, in the first figure he is saying calculate the F1 from here, F2 from here, and F1 by F2 he is asking, okay. Spring of all spring constant, mass spring of same spring constant, all spring are same spring constant here only, and the midpoint at the top end of the figure, rod to oscillate by a small angular displacement, frequency F1, F2 oscillate. Same thing only. So rod is like this, okay. This point is hinged, okay. And first case, here there is a spring, here there is a spring. So if we move this rod little bit displaced, okay, from its mean position, so we can say he will feel a force this side, because this spring was natural length, you moved it like this, so extension happened, so there is an force this side, right? How much that will be force? K into x. Let's say you rotated with angle theta. Okay, so K into x will be how much? This is L by 2. So this will be L by 2. How much? Sine theta, right? L by 2 sine theta. Sine theta is theta only. So you can say K L by 2 theta. This will be the force. Okay, and if you see by this point, so this point, if you see, if I move this rod this side, so there will be a compression in this spring. Compression happened means force will be this direction. Okay, this will be K into how much? L sine theta. So L theta. These are the two forces, right? So here if you write down the torque, you will say torque is equals to force, that is K L by 2 into theta at a distance of L by 2. Okay, plus both will be in the same sense and restoring only, so negative sign you don't have to write down, till we already considered, right? Plus this will K L theta, that is force, into L, this is the torque. Okay, and torque equals to I alpha. Moment of inertia you don't have to write down, because both way moment of inertia will come same, so don't go in that calculation. Moment of inertia you keep it I only, right? From both places it will come same only, I alpha. Okay, from here alpha came how much? I can say here theta you take came outside, KL square by 4, and here KL square. So this will come how much? 5 by 4. 5 by 4 KL square theta divided by I is also there. Okay, so I can say this is 5 KL square by 4I into theta. This is your omega square. Okay, leave it here only currently. Second part, or we should be go with the, so we know omega is what? 2 pi by time period is frequency, 2 pi f, so f is 2 pi by omega. Just I want to show that, sorry, omega by 2 pi. Okay, so what I want to show is the frequency is proportional to omega. Okay, so from here f1 you can get, f1 will be what? 1 upon 2 pi. Okay, under root of omega you can write down this 5 by 4 KL square, I also denominator. Okay, this is f1. Next see the f2. Exactly same f2 will also come. Just hold on. Second one is more easier, on this same place only it is. Okay, so in the mid only, if you disturb it like this, okay, what will happen? You will have two forces, if same, let's say theta angle. So here K into L by 2 into theta. This will be your x, right? L by 2 into theta. And this is same, one spring is getting extended, other spring getting compressed, right? So both will have this side only, so multiply by 2. Okay, this will be your net force, this direction on the spring. Okay, so when you will write down torque is equals to this force, which is how much? KL theta into how much distance? This is L by 2. Okay, and this torque equals to I alpha. That's why I told don't put the value of I, because I will be same here also, because about same point it is rotating. Okay, so from here alpha came how much? Theta outside, so KL square by 2I. Okay, and this equal into theta. Got it? So from here frequency f2 will come how much? 1 by 2 pi, that is same only, under root of KL square by 2I. Okay, now from this both, if I get f1 by f2, okay, so final answer is I think f1 by f2 only. So if you want f1 by f2, so if you divide f1 by f2 here, okay, so 5 by 4, everything is, other things are cancelled out, 5 by 4 and divide by 1 by 2, so 2 multiply 5 by 2, under root of 5 by 2 will come. Okay, so under root of 5 by 2, that is your C option. So C option is your answer. Okay, next. See, fourth question. Consider a star of mass m2. So this question have a problem, I will tell. Just hold on. Okay. Consider a star of mass m2 kg revolving in a circular orbit around another star of mass m1 kg, with m1 is very higher comparison to m2. So star is very big comparison to that mass who is revolving. Okay. Heavier star slowly acquires a mass from a lighter star at a constant rate of gamma kg per second. In this transfer process, there is no other loss of mass. Mass is not lost. This mass is not going somewhere else. It is coming to the m1 only. Okay. If the separation between the center of the star is r, centers of the star is r, and relative rate of change of 1 by r into dr by dt that he is asking. Okay. So this question have some problems. See, he is saying mass m1 is higher, right? M1 is a big mass. M1 is a big mass. Okay. And M2 is a mass who is revolving. Let's say with speed v it is revolving. Okay. In an orbit. At a distance is what? R. Okay. Now he is losing the mass and he is getting that mass. Okay. The thing is, if he loses the mass, okay. Now some people will say that because he is here only, everything is shared, so you conserve the angular momentum because force is towards the center only. Because if the mass is m1 is higher, so they will not revolve around the center, right? Around the center of mass. Center of mass is lying in the m1 only. So this is only revolving. Okay, that's why. So about this point, you can conserve the torque is constant, right? About this point, torque is 0. So you can conserve the angular momentum of this m2 mass. But if you see here, if the mass is going from here to here, okay, at a certain point, what will happen? Here mass will become 0, right? Mass will become 0. So angular momentum is not conserved. Okay. So that way angular momentum is also not conserved. You can get the answer. Actually, you will not get the answer also, because what he is asking is 1 by r dr by dt. Okay. 1 by r dr by dt. So r is a positive quantity obviously, and he will move as mass will decrease, he will move away. Okay. So dr by dt is a positive quantity. Okay. But if we see the options, okay, all the options m2 is positive, gamma is given positive, right? Constant rate. So rate is positive only you will put. These all values are negative. Okay. So you can't match any option. Okay. If you want to get any option, still you will not able to get. I will tell you how to solve basically. So first of all, you write down that towards net force towards the center equals to centripetal force is giving. So I can say m2 v square by r is equals to towards the force g m1 m2 by r square, right? From here m2 got cancelled out, so v came what? Under root of 1r got cancelled out, and this came out g m1 by r. Okay, this came. Now you say angular momentum conserved. By that you can get an expression, but you will not get the exact answer. See why? This is the angular momentum. So m2 v speed and r distance from the center from the m1 is constant. Okay, put the value of v. m2 v value you can write down under root g m1 by r here in multiply equals to constant. Okay, if you see clearly here, g is a constant you can send that side. So and m1 is not a constant. Okay, so what you have m2, okay, then you have here m1 to the power half, and then you have r to the power half equal to constant. Let's take this expression in the new page. m2 into m1 to the power half r to the power half equal to constant. As we do in the percentage calculation, take log and differentiate. By that it will come, because we know here he is asking 1 by r dr by dt. So if I take log and differentiate, 1 by r will also I get, and dr by dt also I will get, and that dm by dt will also get gamma. Okay, so that we can take. There are many problems here, just see here. So if I take ln, so we can say ln m2 plus half ln m1 plus half ln r equal to constant. Sorry, ln constant will only come. Okay, so here you can say differentiate, so 1 by m2 dm2 by dt, rate of change of mass of m2, plus 1 by 2 m1 dm1 by dt plus here 1 by r 1 by 2 and r also dr by dt equal to 0. With respect to time you differentiate. Okay. Now as you are saying that mass m1 is very big comparison to m2. So here m1 is very big comparison to m2. So here we can say this quantity will get 0. Okay, approximate, right? Because m1 is very big comparison to m2. Okay. So here this dm by d2. So m2 is what? This mass, na? M2 is which mass? The smaller mass, right? So he is losing the mass. Okay. So rate of change of mass for him will be minus gamma, right? So for him, for M2 mass, rate of change of mass is minus gamma. So here you will put minus gamma by M2. Okay. And this quantity is what? Plus 1 by 2r dr by dt equal to 0. Okay. Take this that side. So 2 also that side. 1 by r dr by dt, okay, is equals to how much? 2 gamma by m2. Okay, that you can say. Okay, but the problem is that 2 gamma by m2. So here negative sign is there. As I told that r is a positive, dr by dt is r is increasing, so dr by dt is positive quantity. Okay, so it should come positive, but he gave here negative. So I don't know. So this question is a controversial. Let's see JEE Advanced what gives answer for this question. Okay, then only we can say something about it. If JEE Advanced gives or we will get some answer, we will upload that video also. Okay, later on. But currently this is the what my opinion is. Next section 2 we have. Okay, so in section 2, fifth question. Okay, section 2 is as it was in paper 1, same as paper 2. Partial marking is there, plus 4 minus 2. So we have here a positive point charge of 10 to the power minus 8. Okay, is kept at a distance of 20 cm from the center of a neutral conducting sphere. Conducting sphere, okay, neutral. Currently studying neutral. Of radius 10 cm. Okay, so this is 10 cm radius and one charge is kept at a 20 cm distance. Okay, the sphere is grounded and the charge on the sphere is measured. Okay, the grounding is then removed and subsequently the point charge is moved by a distance of 10 cm. So already 20 and you moved by a distance 10 cm further away from the center of the sphere, means total now 30 cm. Okay, in the radial direction. So in the same direction 10 cm. Okay, taking k equal to 9 into 10 to the power 9, where epsilon naught equals to this and the following statements. Before the grounding, so before grounding, the electrostatic potential of the sphere is, okay, before grounding. So situation is like this: sphere, charge q. Okay. Let's say this distance is small r, radius is capital R. Okay. Before grounding, if we go with the A option, before grounding, potential is because of this charge only. So I can say kq by r. K is 9 into 10 to the power 9. Q is 10 to the power minus 8 as for think, yes, and divided by small r. Small r is 20 centimeter initially, right? Before grounding it is 20 centimeter. He's explained the situation, right? Initially it is close 20 centimeter. Then after grounded, okay, then charge flown or whatever. And then after, when he removed, it went away. That's what. So first he is saying that when this is the situation before grounding, okay, that time what is the potential? So 20 centimeter means 0.2 meter. Okay. If we solve this, okay, 2, 9, 10 to the power 10. 2 will come, 9, 4.5, 450. 450 answer. Okay. So A option is correct. Fine. A option is your answer. A option is your answer. Fine. Now he's saying charge flown from the sphere to the ground because of grounding is, okay. So charge flown means you grounded this, okay. Okay, then how much will charge will flow? So potential should be 0, right? Okay, so potential you make 0. Fine. So 0 is equals to, first let's say charge came Q on this. Okay, if we calculate the Q, then answer we can give. Hold on. Q, so K Q by capital R plus K capital Q by small r, this should be 0. Okay, so here I can say what? Small q is nothing but minus Q by capital R by small r. Okay, small q minus 10 is to power minus 8 into capital R is 10 na? 10 centimeter, that is 20. So 10 by 20, you convert that in the meter, still it will come 7. Okay, this is it coming? 5 into 10 is to power, okay, 5, 10 is to power minus 9 he is writing na? So you can take 5. Okay, Q is equals to minus 5 into 10 is to power minus 9 coulomb. Okay, here on the sphere charge is negative. So flown charge is positive only, right? So charge flown from the sphere or to the ground because of grounding is this. Correct. B option is also correct. After grounding is removed, the charge on the sphere is minus, right? So you bring the charge on the sphere, minus will come, right? When this charge came, positive charge. Here there will be negative, here there will be positive. Then you grounded, positive went, negative kept. So negative is there, positive charge from. Okay, because potential we want 0. Overall potential, right? So grounded, potential 0. So this is the charge. So B and C option both are correct, right? After grounding is removed, charge on the sphere that we calculated minus 5, right? Into 10 is to the power minus 9. D option, the final electrostatic potential of the sphere is. Final means moved away also, right? Okay. So final, if you want to write down final potential, I can say K small q by capital R, okay, plus K q by, now it moved away, right, means 0.3. Okay, so we put the value, I can say 9 into 10 is to power 9 into Q is now 10 is to power 5 into 10 is to power minus 9, but negative na, so minus 5 into 10 is to power minus 9, right, divided by R, that is 0.1. Plus here K capital Q is 10 is to power minus 8, as always K value is 9 into 10 is to power 9 into 10 is to power minus 8 divided by R is 0.3. Okay. Potential came how much? So if we see here, 9 5s are 45, the minus will come, this got cancelled out, 450. 10 is to power 9 minus 9 gap, 9 5 45, 0 will come, minus 450. From here 1 3 10 is to power 3, so 2 0 will come, 300, okay, plus 300. So this came minus 150 volt. Okay, so minus 150 I am getting. He is saying 300. So D is not correct option. Okay, D is not the correct answer. Next. So two identical concave mirrors, each of focal length. Okay, so in modules we have seen the questions like this, where we say image form on the object only, and the previous papers also some questions came like that, but not with the mirror. Mirror cases in the, with the lens one question came, that you have in the water, you have a lens like that. JEE Advanced asked previously questions. Okay, paper is same way only, like geometrical optics, okay, those questions only, and then somewhat wave optics will be asked, and then electrostatics, right? Paper 1 we have seen the magnetic, right? So like that there will be paper only, same pattern. Two identical concave mirror, each of focal length f, are facing each other as shown in the schematic diagram. Focal length f is much larger than the size of the mirror. A glass slab of thickness t and refractive index n0, okay, thickness is given total t and refractive index n0, is kept equidistant from the mirrors and perpendicular to their common principal axis. Monochromatic point light source S is embedded at the center of the slab on the principal axis. So here is your monochromatic source. Okay, as shown in the system schematic diagram, for the image to be formed at on S itself, which of the following distance between the two mirrors is or are correct? So distance between the mirrors, total this distance. So see once, the question is this, that in module you solve this question as like this. If I put here my source and I have two mirrors like this, and I want to make the image on the source only. So one condition is, if this source is at focus, right, then this light can go on the mirror and will become parallel, okay, and then hit it, and then again it should come on the focus. So this focus should also here, this focus should also here, right? So this is F, this should be also F, okay. So D equal to 2F should be the condition. One more possible thing, that if I have source here, okay, if this light goes straight, hit here, okay, and come back on the same path, and then again hit here and come back on the same path, so image will form here only, right? So that's what is the meaning of this. This is the center of curvature, so I can say this is your 2F and this is your 2F. So D equal to 4F, okay. Now in this particular question, he made that there is a slit also, right? So how we will do? So see, one side you will check, other side automatically it will come. See how? For this, I am drawing little bit bigger, then this way, like this, bit closer. Source is in the middle, yes, as source, okay. What we are saying is that from this source light should go, okay, either it should appear that it is coming from the focus, so that it goes parallel, okay, and then come back to the same point, right, from same, okay. So that's what. So here this distance is t by 2, okay, this side t by 2, okay. So this total is d, right? So this from source, if it is in middle, this is d by 2, right? So t by 2 is this, so this is how much? D by 2 minus t by 2, correct? Okay. Now as we said in the previous diagram here, okay, this should be F, okay. So what we are saying here is that the fish case, right, that case, so that you consider the source moves this side S dash, okay. Source appears to be here, okay, like light will go like this, okay, and then it bends towards this point, so source will come here, like this it appears, okay. I will draw that diagram, okay, hold on. So this S dash came here, so this distance is how much? How much this will be? I can say t by 2 n naught refractive index, right, okay. So this should be your focus. So I can say that focus F should be equal to what? T by 2 n naught plus d by 2 minus t by 2. Correct? Understand, like this way. This should be focus, right? So that way. Understood? What he is asking? The distance between the two mirrors is, okay. Distance means d is asking, so calculate the d from here. So multiply the 2 this side, okay. And then take this quantity this side. So you can say d is equals to 2f, okay. And then t take common. What he is keeping outside? If you see the options, plus is outside, okay. So plus we have to keep here. So this will become positive, that side. So you will have t common 1. This will become negative, minus 1 by n naught, I think, right? T by n naught, negative it will become that side. This will become positive, correct, okay. So which option it is matching? 2f 1 minus 1 by n naught into t, right? B option, okay. Now see, understand, as you said, this particular case you said this is f, okay, but this distance can be at 2f also. So wherever you are putting the f, there you can put 2f, right? By this, because you have to consider this and this both cases, right? So that's why you will say wherever you put f, here you will put 2, this 2 will come, this will become 4. So another option D will come what? This will become 4f. 4f plus t into 1 minus 1 by n naught. Okay. So this can be your also answer. So which is option number A, right? So that's how option number A and B came. Understood? Now what we are saying here is explanation wise, understand how the light ray will go. Light ray will start from here, but it will bend, right? So it appears to be coming from here. Let me draw a straight line here and then bend. So appear to be from this side, and then because of that it is coming from focus, so it will go like this straight, and then appear to be coming on this one here, but go like this here. So same, it will interact, okay? And you take center of curvature case, so something like this only happens, but just it will come back straight forward, okay? It will come back in the same straight line, and then again bend and come to the source, then here came, then again bent and came there, then again hit, right? Understood? So I hope this question is clear. Okay, what we got? A and B option. Understood? Next question. So what we have is 6 infinitely large and thin non-conducting sheets are fixed in configuration 1 and 2 as shown in the figure. The sheets carry uniform sphere surface charge densities which are indicated in terms of sigma naught. Okay, the separation between any two consecutive sheets is D. Let's call it D. Okay, the various regions between the sheets are denoted as 1, 2, 3, 4, 5. Okay, here also. So 6 here, 6 here. Okay, and then sigma naught value is given. Then which of the following statement are correct? Okay, so what he is asking, the region 4 of the configuration 1, the magnitude of electric field is 0. Okay, electric field he is asking. So first of all, electric field formula we know, sigma by 2 epsilon naught, right? Sigma naught he is saying, so let's call it sigma only. Okay, sigma by 2 epsilon naught. This formula we know, independent of the distance from the surface, right? So large, infinitely large, so infinite, that only the formula. Okay, so if we see here, okay, electric field when you will consider, so fourth region is, what is the first question? Fourth region, na? Region 4, right? Configuration 1. Configuration 1, region 4. Let's draw the diagram here only, 5. Okay, sigma by 2 epsilon naught we know already. One, 3, 4, 5, 6. Okay. For your comfortability, I am writing larger. 1, 2, 3, 4, 5. Plus sigma naught minus sigma plus sigma minus sigma plus sigma minus sigma. Correct. Final is minus sigma. Correct. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5th region. Okay, and same diagram is in the next page also. So we have to draw little bit with changes, obviously. 1, 2, 3, 4, 5. Okay. What is the changes at the end? That's it. Plus sigma by 2 minus sigma plus sigma minus sigma plus sigma by 2. Okay, that's it. Sorry, plus minus plus minus plus minus. So 1, 2, 3, 4, 5. One more, na? Calculation wise it is very easy, plus sigma and minus sigma by 2. Okay, now regions are 5 regions. 1, 2, 3, 4, 5. Fine. Now what he is asking in the configuration 1, which is this. Okay, configuration 1, first option. Configuration 4, configuration 1, region 4. Region 4 magnitude of electric field. So here in region configuration 1 this is, okay, and this is configuration 2. Let's not get confused. Just draw on the diagram for your comfort. So configuration 1, region number 4. Okay, so here if you see sigma by 2 epsilon naught will come from everyone, but positive negative will neutralize, positive negative, so this side no electric field will come from this side. This side also 0, so this electric field is 0 in this region. Okay, so 0, 0, 0, correct. So A option is your answer. Okay, next B option. In region 3 of the configuration 2, region 3 of configuration 2, region 3 means this region. Okay, so here I can say plus minus neutralize, plus minus neutralize. Okay, this plus will have electric field this side, and this minus will also have this side only, right? So in region 3, we'll name it E3. Okay, E3 will be how much? Sigma by 2 epsilon naught, and both will be added because both in same direction. So sigma by 2 epsilon naught. So this is how much? 4, 2. Sigma by 2 epsilon naught. Okay, so E3 is nothing but sigma by 2 epsilon naught, but he gave sigma by epsilon naught. So this is wrong. Okay, potential difference between the first and the last sheet of the configuration 1. Configuration 1, potential difference. So we know distance is given a d, right? So electric field you find out, multiply by distance. If you are going in the same direction of the electric field, potential will decrease. If you are going opposite to that, potential will increase, right? So if I see in this region, okay, this region positive, so this side, and because of this neutralize, because of this neutralize, because of this, it will come this side, right? So here overall 2 are there, sigma by 2 epsilon naught because of this, sigma by 2 epsilon naught this side, right? So this here electric field will come this side, which will be E1, let's say sigma by epsilon naught. Okay, in this region this neutralize, this neutralize, this neutralize, so here E equal to 0. Okay, and because of this, in this region if you see, this is neutralized, this is neutralized, this will come this side, this will come this side only. So here also same thing is happening, E3 will come sigma by epsilon naught. Okay, and in the E5 you will have, this will come this side because of this neutralize, last one is remaining. So same exactly same. E5 will come how much? Sigma by epsilon naught. Okay, so in this side you are going, so potential will decrease, but how much will be the potential difference? If we say potential difference, sigma by epsilon naught, how much distance? 3d, right? Put the values. Sigma value given how much? 9 into 10 to the power minus 6. 9 into 10 to the power minus 6 into 3 into d. D is how much? D 10 to the power minus 6. 10 to the power minus 6 divided by epsilon naught. Epsilon naught 9 into 10 to the power minus 12. 9 into 10 to the power minus 12. Okay. From here how much you got? 9 got cancelled out. 3. This comes 3, right? So 3 option is here 5, right? So this is given 5 volt, we are getting 3. So this is not correct. Next, potential difference between the first and the last sheet of the configuration 2 is, okay, configuration 2 also we have to calculate all the electric fields. Okay, E3 we have already calculated, which came actually how much? Sigma by 2 epsilon naught. Okay, because of what? Because there was a sigma by 2, that's why it was come sigma by 2 epsilon naught. Okay, similarly I will calculate here also. So in this one, if we see here on 1 also, this got neutralized, this got each other, they will cancel out. Here also they will cancel out each other. This effect and this effect will come, same as came here also, right? Same here. So here it will come sigma by 2 epsilon naught this side, right? Here if you see, so here this is negative, right? This is minus 1 here, half plus, so negative only, so this side because of this side. Okay, and here this got neutralized and this side is positive. Positive means this side. So overall this side same amount, so sigma by 2 epsilon naught. Okay, here you understand the minus sigma by 2 will come, right? Minus 1 by 2 is remaining, right? Because of that. Okay, and because here also my plus 1 by 2, so this side effect. Okay, similarly when you will calculate, here we already calculated, here it will come which direction? See, plus 1 by 2, so this direction, and here this got cancelled out, this is minus 1 by 2, so this side, so it will again this side switch, sigma by 2 epsilon naught. Okay, now in this region if we see, this region is how minus sigma, so going this side, and this neutralize, this is giving this side, so this again this side sigma by 2 epsilon naught same. Okay, so if I see here, okay, here if I'm moving in the direction of electric field, potential decrease, again same amount increase. If you write down here potential difference, okay, what you will write down? So V, you write down this as V1, this side V2, okay. So you say V1 minus will come, minus sigma by 2 epsilon naught into d distance you travel, then plus sigma by 2 epsilon naught into d distance. If you're going opposite to electric field, you will have the increment in the potential. Then again decrement in the third region, so minus sigma by 2 epsilon naught into d, and here again increment plus sigma by 2 epsilon naught into d, and then again here decrement minus sigma by 2 epsilon naught into d, then is equals to V2, right? So if we see here, clearly we can see that this value cancel out, this cancel out, but V1 minus V2 have this value, sigma by 2 epsilon naught into d, right? So in option D, he is saying 0, that is non-zero, right? So we will say that is not the correct answer, right? Because he is saying 0, we are getting some value will come, na? Sigma by 2 epsilon naught into d, that value will come, right? No need to even calculate because he is saying 0, so he is wrong, right? Next question. The efficiency of Carnot engine. So this question was doable, okay? Very much doable, okay? Next. So you have to identify those kind of questions only, okay? In the exam. And then it's not like if any question is hard, it is hard for everyone, right? So leave that question if you are not able to approach that question and go to the next question, okay? Then try out. You have to save maximum amount of time. In JEE Advanced, you also know that it is not about how many questions you are doing. It is also about that how many questions you are leaving before they start wasting your time, right? Efficiency of Carnot engine operating between hot reservoir is given 1000. Efficiency is 0.4, okay. Hot reservoir 1000 Kelvin only, right? 0.4 efficiency. So here, let's say this is Q1, going this side Q2. Okay. It extracts 150 joule of heat per cycle from the hot reservoir. So 150 joule. So this Q1 is nothing but 150 joule. Okay. Okay, and then the work extracted from the engine is being fully used to run a heat pump. Okay, in that thing we will go later on. Just hold on. Okay. So from here there is a work done that is used by a heat pump. So heat pump we will go later on. Here let's say there is a T2, second reservoir. Okay. He is saying efficiency of options. If you see, 2 options are for Carnot engine and 2 options are for heat pump, right? So let's solve for the engine. So he's asking the temperature. Let's calculate this temperature. So temperature you will calculate how? Efficiency is given na 0.4. So you say 0.4. What you will say? 0.4. You can do here. 0.4 equals to 1 minus temperature, this T2 by 1000. Okay. So you can say T2 is equals to 1000 into 0.6. T2 is equals to 600 Kelvin. Okay. 600 Kelvin. Is it 600 Kelvin? Yes. So B is your correct answer. Okay. Next, A option, if we see, because Carnot engine we are solving, so first let's solve Carnot engine. Work extracted. So how much is this work? This W is how much? Okay. So we know efficiency, we also know 0.4. Efficiency we say work done by Q1, right? So from here work done came how much? 0.4 into Q1, that is 150. Okay. 0.4 is nothing but 2 by 5. Okay. So this is 60 joules, right? So work done came 60. Okay, so this is nothing but 60 joules only, right? So that's it given. A option is also correct. Okay, this we know already. Efficiency meaning is the useful work he is doing and how much energy we gave to the system. So we are giving Q1 and his useful is what? W. Useful by Q1. Okay, that's how you write down. So work done came. Now he is saying in the heat pump case that the work extracted from the engine is being fully used to run the heat pump which has a coefficient of performance 10. Hot reservoir of the heat pump is at temperature this. Okay. So if you take the case of heat pump, just hold on. This is work done thing. You have noted, I hope. Okay. So I will shift it here. See now, there is a heat pump. So heat pump is something like this, and using this as the energy. Okay. And there is a hot side temperature that he is saying as a how much? 300 Kelvin, right? Hot reservoir 300. So this is 300 Kelvin. Let's say T3, T1, T2, T3. Let's name it. Okay. So what is the use of this heat pump? How we use the heat pump? From the lower temperature T4, he extracts the heat and throw in the higher temperature. That's what. Okay. So let's this named as Q3 and Q4. Okay. So that's what he do. Okay. Next what? Any other information? Coefficient of performance is given as 10. Okay. See the coefficient of performance. So what is the meaning of coefficient of performance? Okay. Useful work. What is our useful work? Q3 na? Q3, like take the example of refrigerator. That only I explain always. Q3 is the useful thing he is doing for us. Making the refrigerator cooler. Cooling, like more cool, right? So Q3 is the useful work. What he is taking? Electricity, which is coming from me, this side, energy. So 60 is the, he is coming, taking. So Q3 by W, which is 60. So Q3 is 600 joule. Okay. So in the options, if you see, heat supplied to the hot reservoir of the heat pump is 540. Okay, that we will see. Here we can say this is 600 Q3, right? Okay, so if Q3 is 600, this is 60, right? So both are coming. So this is 600 this side, 60 this side. So this is 660 na? Inside equal to outside, 660, right? So that answer not matched, right? He said 540, we are getting 660, right? So D is not correct. C option, temperature of the cold reservoir of the heat pump is 2. So cold reservoir side, Q3 already came. So we know T3 by T4 is equals to Q3 by Q4. Sorry, I mentioned here name wrongly. Okay, so this T3 by T4. Here according to these names, okay? According to these names if you go. Or did we use any temperature? No, no. So we can replace the names. T4 and T3. Right? Fine now. So here T4 Q4 should come and T3 Q3. So that's how it goes. Okay. T4 by T3 equals to Q4 by Q3. Okay. So by this T4, how much? T4 600, 300. T3 you want, right? So T3 you want. So keep everything this side. So Q3 by Q4 multiplied by T4. So Q3 is how much? 600 by Q4 is how much? 660 multiplied by T4, that is 300. Okay, so this is 0, 0, 60, 6 table we can cancel out. So T3 will come 0, 6, 10, 11. 10 by 11 into 300. Okay, so this is 270 he gave exact. 270 is not coming. This may become to around 270, but exactly 270 it will not come, right? So C option we can't say because he said exactly 270. None of the approximation he can say. So C option is also not correct. The answer is close to 270 but not 270, right? 10 by 11 into 300. Okay, this is your question number 8. Understood? A and B option is your answer. So I think this was the doable question. Everything is taught and explained in the same manner as I did here. And many questions also we did like this only, but we didn't connected the same energy used by the heat pump, but heat engine and heat pump we have solved separately, right? Next. Section 3. So in section 3 what we have is question number 9, okay, paper 2. Conducting solid sphere of radius r and mass m carries a charge q. Sphere is rotating about an axis passing through its center with a uniform angular speed omega. Okay. The ratio of magnitudes of magnetic dipole moment to the angular momentum about the same axis given. Okay. solid sphere but conducting. Conducting means all charge is on the edges, right? So if we see whole charge is on edges, so we can say magnetic moment. How we solve for magnetic moment? By angular momentum. So angular momentum that side multiply. Okay, and what he is asking? Q by 2m. Okay. So that we know magnetic momentum. Let's write out with mm because that is mass is that, na? So Q by 2m into angular momentum. So charge is on the surface, right? If we consider a solid sphere who have charge on sphere like surface, right? Surface now conducting. So charge is on surface. So this is a hollow sphere according to this, right? So hollow sphere moment of inertia, angular momentum. Angular momentum is I omega, right? So moment of inertia will write down. Moment of inertia, what you will write down for hollow sphere? 2 by 3, right? mr square, okay, into omega. Okay. And then if you write down, we have to divide with the angular momentum. So angular momentum L is what? I omega, but here it is a solid, right? So for that you will write down 2 by 5 mr square into omega, right? Ratio he is asking, so divide both of them. Here mr square omega cancel out, q by 2m. Q by 2m he is keeping the factor, okay, as it is. So ratio when you will calculate, q by 2m as it is, multiply by here 2 by 3, okay, and this will become 2 and by 5 will go in numerator, right? Sorry, here 2 by 3 na, 2 by 3. So this is q by 2m into 5 by 3, right? So 5 by 3 is the answer. 5 by 3 means that only 1.67, 1.666, so approximate 2, if you round off 1.67, right? That's it, question number 10. So understood na? This formula is in notes. Angular momentum we know, ratio came. Easiest question possible. 9th, 10th. Hydrogen atom initially at rest in its ground state absorbs a photon of frequency F1, let's call it, okay, and ejects an electron with a kinetic energy of 10 electron volt. Okay. Okay. The electron then combines with a positron at rest to form a positronium atom in its ground state and simultaneously emits a photon of frequency F2. The center of mass of the resulting positronium atom moves with a kinetic energy of 5 electron volt. Okay. It is given that the positron has the same mass as that of the electron and the positronium atom can be considered as the Bohr atom in which the electron and positron orbit about its center of mass. Considering no other energy loss, the difference between the photon energies. Okay. He is saying that there is a hydrogen atom. Okay. So we know electron and proton. So here the energy is minus 13.6. Okay. So if I give him a HF1, right, that only is saying, then what happened? This electron left it and left with what? Left with a kinetic energy of 10 electron volt. Okay. So how much is this? I can say from a ground state, you have to bring it to infinity to make this potential 0, and then you gave the kinetic energy also, right? So I can say initially minus 13.6, okay, and then you gave him what? HF1, and it got the 10 electron volt kinetic energy. So HF1 is nothing but 13.6 plus 10, that is 23.6. You can directly understand that first we have to, this potential energy stabilize, you have to send him to infinity. So increase his potential energy and give him the kinetic energy. So total energy that you have to give is the sum of both, right? You have to make it stable system, na? So potential energy you have to make 0 of this system, electron plus proton, to send him infinity, and then at that point you have to give 10 electron volt. So this is the HF1, okay? You have to get the HF2 also and then difference of that, okay? So see what happened. This electron which is moving with 10 electron volt, okay? There was a positron, okay? With same mass but positive charge, okay? It came here and they started revolving around center of mass. So same mass, right? Here what happens? Here proton have very high mass, so this electron rotates around the proton, okay? But here both masses are equal, so they will rotate around the center of mass. Okay, so by that we can say that here the factor which comes, okay, that is because of this mass only, but here both masses will come. So in the potential energy term, reduced mass will come, right? So due to that, we have seen in the notes that it comes minus the energy, system energy comes minus 13.6 by 2 because of reduced mass, m1 m2 by m1 plus m2. Because of that, 2 factor comes, m1, both are equal, m into m by m plus m, right? There it comes m by 2 factor, okay, and here m only because this only, right, 1 only moving, that's why. So m by 2 factor will come, so that's why 1 by 2 factor comes. That's the energy of this system, okay. And he said the system, the center of mass is moving with a kinetic energy of 5 electron volt, okay. So what we have is, and one more thing he said, moving with 5 electron volt, and he simultaneously emits a photon of frequency f2, right? So initial is this 10, okay, 10 electron volt. If we see here, this came 10 electron volt, and what he made here is 5 electron volt center of mass energy, and this is minus 13.6 by 2, how much? 6.8, na? 6.8, right? Correct. Minus 6.8. So minus 6.8, okay, plus he left an, what we say, photon also of F2, right? HF2 energy, right? So that is it. Okay, this is the system energy, this is the potential, this is the kinetic. So from here HF2, if we see, okay, this is 5, and then this will come add 5 plus 6, 11, 11.8. Okay, so what he is asking is the difference of these two. So actually this is nothing but 23.6 minus 11.8, that is 11, 11, 22, 11.8 only, 11.8 electron volt. That's your answer. The difference of these two is asking. Here you have to understand this thing which is also in the notes. Reduced mass will be considered and both are of same mass, right? So that's it. 11.8 is your answer. Okay. So you have to understand this thing. That this thing, if you understand, then this is kinetic, this is potential, this is energy released, he did extra. Okay. So that's why you write down energy conservation here also, right? Here it was very easy. Here we have seen many times. If it is leaving with some energy, then this is how you will write down. Okay. And here you have to consider this thing also. That's it. Next. 10th done. 11th. Okay. So 11th what we have, an ideal monoatomic gas of n moles is taken through a cycle WXYZW. Okay. WXYZW. Okay. Consists of a consecutive adiabatic and isobaric quasi-static as shown in VT graph. VT graph. So VT graph, this XY and WZ is your isobaric, I can say, right? Pressure constant, right? Next, he gave the volumes of WXY 64, 125 and 250 respectively. If the absolute temperature of the gas here at W is TW at the point W, so that NR TW is equals to 1 joule amount of heat absorbed in the XY process. See, let's draw this diagram in the main here. So diagram is something like that. Here center, here it is like this, somewhat like this, okay, and then like this, and then like this, then like this. Okay, I am drawing this rough diagram. Okay, let's name the point XY, WXYZ, WXYZ. Okay. Process is like this. Okay. Here what values he gave? WX and Y. WXY 64, 125. 64 volume at W, 64 centimeter cube. Volume at X, 125 centimeter cube. 125 centimeter cube. And volume at Y, 250, right? 250 centimeter cube. Okay, that's it. Next, see. Next what else is given? Here he said TW, temperature is TW. Okay, so he is writing nRTW is 1 joule. Okay, N is number of moles, so nRTW is 1 joule. This is the information given. Okay, now he is asking what? Then the amount of heat absorbed by the gas along the path xy. Okay, along the path xy, this xy, this is isobaric, right? So isobaric heat, what you write down? First you have to understand what I write down, then only you will able to understand that how we will reach there. Okay, so we say monoatomic given na? Monoatomic. So I can say F by 2 plus 1 into nR delta T I write down. So I can say P delta V also na? P delta V. Instead of nR delta T, I can say P delta V, P delta T or delta V also, right? So in P delta V, I know the delta V already. If I get the pressure here, X or Y position, both are same only pressure, right? So if I get that pressure, then I will just done. Then I am done. Okay, because degree of freedom I know, delta V already I know. So I have to get the pressure only. Pressure how we will get? Pressure I will get from the adiabatic process. He said this is adiabatic, X to W. So get the X to W adiabatic process. Apply. What you will say? Move this little bit this side. What we can say adiabatic? Adiabatic we can say here apply adiabatic, right? So PV raised to power gamma we can say. So Px into Vx raised to power gamma, okay, is equals to Pw into Vw raised to power gamma. Okay, so what we know, both volumes we know. Here pressure Pw we don't know, right? It's okay, hold on. Okay, I will replace from here. nRTW is 1 joule, so I can say nRTW is also equals to Pw into Vw, right? So from there I will replace, just hold on. Okay, so here Vw I know, so Pw came what? Pw I know na, 1 joule divided by volume. Let's keep the volume in the centimeter cube only. So Vw is 64 centimeter cube. I will write down the unit because I don't want to convert. I will tell you why. Okay, 1 by 64 centimeter cube Pw came. Next what? Here Px I want to calculate Px. Okay, so here Pw, keep it as it is. I will put the value later on. Here Vw by Vx raised to power gamma. Okay, so Px, now put the value. Pw will put later on. First you will put this. Pw is what? 64. Vw 64 by Vx 125 to the power gamma. Gamma is how much? Gamma you can say F plus 2 by F. Okay, so that you can say 5 by 3. Okay, so 5 by 3 if you give power, okay, into Pw as it is. Px how much? 64. This is nothing but 2 cube into here 4 cube na. This is 4 cube divided by 125 is 5 cube. Okay, this to power 5 by 3. So into Pw is there. Okay, so you can say this is what? 4 by 5 to the whole power 5. Okay, into Pw. Okay, let's keep it like this only. So there we write down Px only. Px we can write down. So Q what you will write down? Q what you can write down? F by 2 plus 1, 3 by 2 plus 1, 5 by 2 into Px. Px value is how much? Here if you solve, this came 4 by 5 to the power 5 into Pw, okay, into delta V, delta V is this. Okay, so Q is what? 5 by 2 into 4 to the power 5 divided by 5 to the power 5 into Pw. Pw you put 1 joule by 64 centimeter cube. So put it 1 joule by 64 centimeter cube. Where I am not putting in SI unit, I am being careful here. Okay, to write down this. Why I wrote like this? Because delta V is what? In centimeter cube only will come. Subtraction. So 250 minus 125, that is 125 only, right? And 125 is nothing but 5 cube. Okay, delta V. So I hope you understood this thing, right? Q is equals to, now if I see here 5 to the power 5, right? 3 here, 4 here, right? 1 is only remaining, right? And here 4 4 is 16, 16 64 gone. Okay, so here power 5. So this is power 5, this 4 gone, 1 by 5 will come, okay, into 1 by 2 is this one, and 4 to the power 5 you can write down 4 cube into 4 square, 4 square you can keep, 64 went with this. Okay, this is remaining 16 by 10. Q is equals to 1.6. Don't do a calculation mistake here. Okay, I will explain again. I had this yellow data. Okay, yellow and green one I mentioned, that is I had the data. Okay, I know NRT, PV equals to NRT, by that I can see this also, right? Why I clicked this in my mind, what he asked the Q in this process, right? So Q he asked means Q is, I can write down F by 2 plus 1 into NR delta T or P delta V also. P delta V because I have the V delta V already, I need the P only. And I know this is the process, an adiabatic process, so I know the volume here, okay, and I know one more relation between P and V. So from here I got the P also, and V also I know. Here I know the V, so I can get the P by the adiabatic process, okay. So I got the P from there, and I wrote the Px, I got the Px, right? So Px and Py both are equal, so that's how I write, okay. Now calculation mistake should not be there. I kept the 1 joule because Q at the end I need the 1 joule, okay. Delta V I kept in the centimeter cube, so here this is also in centimeter cube, so no problem, okay. That's it. I hope understood, okay. Next question. Geostationary satellite above the equator is orbiting around the earth at a fixed distance r1 from the center of the earth, okay. A second satellite is orbiting in an equatorial plane, opposite direction, okay. That's important, opposite direction to the earth's rotation at a distance of r2 from the center, okay. R2 is smaller, R1 is bigger. The time period of the second satellite as measured from the geostationary relative, okay, is this, okay. So what we have is, this is Earth, let's consider, in outer orbit, okay. You have one satellite which is at r1 distance, okay, rotating let's say with omega 1, okay. And this satellite, anything other information? Obviously time geostationary, so time period is how much? 24 hours, right? So I can say T1 equals to 24 hours. This I know, okay. Then he is saying another satellite. So here we can see R2 is smaller, okay. So he is saying there is one more satellite, okay. So which is at R2 distance, okay. And this is going in opposite direction. So omega 2, okay, opposite, okay. So relative we say omega 1 plus omega 2 will come, right? That's it. So what is our thing? Time period na? So due to one rotation, right? So I can say relative omega is omega 1 plus omega 2, and let's say time period is t, so that is should be 2 pi, right? That relation I know. So from here I want to get the t, right? So let's put the omega 1 and omega 2. So what you do is send this time period that side. So you can say 2 pi by time period is equals to omega 1 is 2 pi by t1 plus this is 2 pi by t2, okay. T I want to get, t is what? T1 T2 by T1 plus T2, fine, okay. Now I have to get the T1 and T2, but I know the radius, right? So for that also we have one solution, Kepler's law use. So Kepler's law, what we can say, Kepler's law we can say that time period is proportional to r to the power 3 by 2, right? So by that, so we can say time period is nothing but k times of r to the power 3 by 2, okay, always. So k is constant, so that will be constant for all of them. So next page, if you want to solve, so we can say t is nothing but k into r1 raised to power 3 by 2 into k into r2 raised to power 3 by 2 divided by k into r1 raised to power 3 by 2 plus k into r2 raised to power 3 by 2, okay. Now I know one thing, I know one thing, that T1 is 24 hours, so I can say 24 hours is k into R1 raised to power 3 by 2. For R1 it is 24 hours, right? R2 I don't know. So, okay, but ratio we know, na? So, 1k got cancelled out from here, and k into R1 raised to power 3 by 2, I got the 24, okay. So 1k cancel out, and now we have R2 raised to power 3 by 2 divided by R1 to the power 3 by 2 plus R2 to the power 3 by 2, okay. From here what you do, ratio we have, na, okay. So divide this thing, so 24 by, this will come here, R1 by R2 to the power 3 by 2 plus 1. Okay, like this. And R1 by R2 is how much? R1 by R2 is 1.21. 1.21 is nothing but 11 square, right? 1.1 square. So 1.1 square to the power 3 by 2 plus 1. Okay, this is nothing but 24 by 1.1 cube, right? So 1.1 cube is nothing but 1.331 and that is plus 1. Okay, so 24 by 2.331. Now what he is asking? He is saying this time period is 24 by p. So 24 we kept as it is only 24 by p. So nothing, p is nothing but 2.331. Okay, so we can say answer is 2.33. That's your answer. Okay, next what? Okay, this question was relatively easy, you can say, easier side you can consider. Okay, because more harder question where this is not thermally insulated, those things here, heater, like that questions we have already done, right? So this question was relatively easy. What question is saying is a left and a right compartment of a thermally insulated container of length L are separated by a thermally conducting movable piston of area A. So area cross section A, left and right are filled with 3 by 2 and 1 mole. Okay, let's consider this thing. Why to draw 3 by 2 mole this side, okay, and 1 mole this side. Am I correct? 3 by 2 on the left and 1 on the right side. Okay, L length, movable area of cross section A. Respectively, in the left compartment, the piston is attached by the spring with spring constant K and natural length 2L by 5. If you understand, here piston is there. Natural length of the spring is how much? Natural length is how much? 0.4L. Okay, but compartment length is how much? L by 2, means 0.5L, right? Natural length is 0.4L, compartment length 0.5L, means the spring is stretched, so there is a Kx force this side force Kx, right? Because natural length is 0.4L, this is natural length. Okay, L natural spring, but he is 0.5L, right, from here to here. So that's why spring is stretched, so force will it will come back this side, left side force will come Kx. And what is the value of x? I can say x value is 0.1L, so K into 0.1L. Okay, this will be your force, spring force, right? Why I am writing and you will come to know. Okay, in thermodynamic equilibrium, the piston is at distance of L by 2 from the left and right edges of the container as shown in the figure under the above condition. If the pressure is in the right is P. So okay, so right pressure he is asking, right side pressure. Okay, so let's name the pressures as P1 this side, P1 this side and P2 this side. So we want the P2. What you need that you have to confirm P2. Okay, fine. P2 we need. Now here if we see, he said it is in equilibrium and he here also said thermally conducting movable piston. Thermally conducting means both side temperature is same, right? So here this P1 pressure will apply P1 into area force and this side it will apply P2 into area force. Okay, so here if you balance the forces, you can say that P1 into area is balancing what? K into 0.1 L. So you can say 0.1 KL plus P2 into area. This is my first equation. Okay, and what else we can say? PV equals to nRT, I can balance. So what is equal? Temperature, right? So temperature, equate the temperature both side, and both side volume is also same. L by 2 into cross section, L by 2 into cross section, right? So volume is also same. Okay, understand na? Here L by 2, this is L by 2, this is L by 2. Length is same, area of cross section same, right? So volume is same only. So temperature if you equate, so you will say PV by RT. So P1 V by R, sorry, N into R, right? N is what? 3 by 2 into R is equals to P2 into V by N is 1 into R. Okay, so 3 by 2 you take this side because I need the P2. So P1 value I will replace, that is 3 by 2 into P2. Okay. Equation number 2. From this equation, which is here, you can place from this P1 value you put there and get the P2. Okay, so P1 value if you put there, we can say this is 3 by 2. P2 into area is equals to 0.1 KL plus P2 into area. Okay, P2 this side, 1 by 2, 2 that side. Okay, P2 into area, or area also you take that side, 0.1 KL into 2 by area. Okay, so P2 is nothing but, so P2, so if we see here, so he's asking KL by A into alpha is there, right? Okay, so KL by A he's keeping as it is, KL by A into 0.2 is there, so 0.2 is only your alpha, so 0.2 is your answer here. So just very easy question, right? So this we can do. Okay, next. Okay, next 14th. So here we have, okay, I hope you have read the questions already. Okay, so what we have is we have slabs. Okay, it is cut A and B, he gave 1.7 this side, 1.5 this side, capital D he gave, small d he gave, thickness of this slit he gave, and your, what else he gave? Here L also he gave. I will explain what is L. Okay, just hold on. So if we see here, okay, what he is saying is, try to understand, this is like this. Okay. Like this, copy here, copy, connect this nearby. Like this. Like this it is. Okay, what is happening here is, this he mentioned as A, so A have a refractive index of 1.7. okay, 1.7, this is 1.7. okay, and this is 1.5. okay, 1.5. Next, what he mentioned here is your slit like this. Okay, so what he is saying is, this is L, L is how much? 1 millimeter. Okay, and this is D, which is from here gap is, okay, here the slit is, so D is nothing but 2 millimeter, and this is also L this side, which is 1 millimeter. Okay, now he is saying this is thickness T total. Okay, and then what he said, 1.5 separation between the slits, T slit, and then he is asking due to the combination of the wedges, the central maximum shift. Okay, that he is asking. Okay, so first of all, let me get these things. Okay, this here, let's name this as T1. Okay, let's get the T1. Okay, so if we get the T1, how we will get? Go with this angle. Okay, let's name this angle as phi. So here I can say 10 phi. Okay, from bigger triangle, I can say this T by this total. Okay, T by this total is 1 plus 2 plus 1, 4. Okay, D equal to, okay, here in this triangle, smaller triangle, what you can say, T1 by, this is 1 plus 2, 3. Okay, so T1 is nothing but 3 by 4T. Okay, so this T1 came nothing but, T1 only, let's keep 3 by 4T. So this is how much? T by 4. So this is also T by 4 symmetric na. So this is 3 by 4T. So total is T na, that's why. Understood? This came. Now what he is saying is, so L2 minus L1, so you draw it like this, that, okay, from here at this, let's say maximum at Y, it is forming L1, and from here distance is L2. Okay, so L1, L2, so we can say it should be equal for the central, right? So L1 minus T. Okay, L1 minus T. L1 minus T plus, here this is L1 na, minus T plus refractive index 1.5 into T by 4 plus Here refractive index 1.7 into 3 by 4 T is equal to L2 minus T. This is L2, this side, L2, okay. L2 minus T plus here T1, this is 1.5 into 3 by 4 T, okay, and plus 1.7. This formula, there's many questions are done like this, okay, so that's why we are doing that one. 1.7 into T by 4, okay. In the notes you can find out this kind of questions, okay. Next, let's solve this thing, okay. So what you can say here, T got cancelled out first of all, okay. Here L1, let's keep this side only, plus this is 5.1, so this is 1.5 plus 5.1, right, 6.6, so this is 6.6, so this is 6.6 by 4 into T is equals to this side L2, and this is 4.5 plus 1.7, 4.5 plus 1.7, 5.2, 6.2, right, so plus 6.2 by 4 into T, okay. So from here I know L2 is bigger, so L2 minus L1 if you calculate, okay, L2 minus L1, so that is 0.4 by 4, right, 0.4 by 4 into T, okay. So what we are saying is L2 minus L1 is equals to 0.4, that is means T by 10, okay, 0.1 by T, this na 0.1 T will come, so T by 10. T by 10 is nothing but D sin theta, and D sin theta is D tan theta is nothing but Y by capital D. So from here Y came what? I can say capital D or T by 10 into capital D by small d. Okay, put the values. T is how much? T if we see 12, right? 12 into 10 to the power minus 6 into capital D is 2 meter, okay, 2 meter, divided by 10 is here and multiply by small d. Small d is how much? 2 millimeter na, so 2 into 10 to the power minus 3, okay. From here if I see 2 got cancelled out, let me use another pen, 2 got cancelled out, okay, and this is, if I see 10 to the power minus 4, 12 into 10 to the power minus 4 meter, okay. What he is asking? He is asking in millimeter, so 10 to the power 3 multiply you can do, so that is 1.2 millimeter, okay, right, 1.2 millimeter, answer is also 1.2, okay, we got the answer. So I hope this is clear. 1.2 is your answer. Got it na? Central right fringe for that. It will form here y distance away 1.2 millimeter away. Next, this question, projectile of mass. So projectile is there, okay, and then he said viscous force is also there. So it experiences a viscous force opposite to its velocity, negative sign c is there, where the drag coefficient is c value is given. V is the instantaneous velocity of the projectile. The projectile hits a vertical wall after 2 seconds. Mass is given, angle of projection is given, initial velocity is given, viscous force he is saying like this, c value given, V projectile hits after 2 seconds. E value if you need, you can use 2.7. The horizontal distance of the wall from the point of projection is, horizontal distance, see, from here projected, let's say at angle theta, okay. Theta is given to you, u is speed, okay, going like this, let's say wall hit, okay, hit the wall, so wall is here. After how much time? 2 seconds. So after 2 seconds it hit, so you have to find out the horizontal distance, this distance, let's call it x, okay. So at any point of time its velocity is v, let's say this side, okay, which is making angle, okay, let's call this as 60 degree only. Here the angle is 60 only, so that we can take theta there. Theta, why? To increase the number of variables, right? So This is velocity, viscous force is opposite direction, CV. Okay. So here this is also theta. So CV, now if you see, understand, there is one force CV this side and downward force mg is there, right? Okay. So I want to go in x, this x, right? So let's solve in the x direction only, right? So in x direction, what you can say, in x direction, how many forces are in y direction? Y direction I can say mg is there, okay, and downward force CV sine theta is there, okay, and this direction you have CV cos theta, okay, this is the force, right? And velocity if you take, velocity is this direction Vy and this direction Vx, okay, you have to go in the Vx, so V cos theta at a particular point, okay. So now what we see here is, write down in the horizontal direction, you write down, so horizontal direction I can say CV cos theta is the dV by dt, sorry, m into acceleration. Acceleration is how much? dVx in horizontal direction by dt. My horizontal velocity is only changing because of this force, viscous force, right? Mg is not, g is not on the horizontal velocity. Horizontal velocity, this is only changing. So that's why this is the force, net force on the body is equals to mass into acceleration in the horizontal direction you applied. Okay. So this is Vx only, na, V cos theta. So you can write down C into Vx is equals to m dV by dx by dt. Okay. So everything is in x direction only we are solving. Okay. And first of all, this is negative here. Okay. Net force equals to mass into acceleration, but acceleration is opposite to the velocity. So velocity will reduce. So that's why. Okay. Now, what you do, Vx that side, dt this side, or you bring this side. So what you have, dVx by Vx is equals to minus C by m into dt. Understood? From here integration. Let's write down the integration in next page. dVx by dVx by Vx is equals to minus C by m into dt. Integrate from where to where? Initial value is ux that you have, okay, and final value let's consider Vx only, okay, at the final point here, and is hitting here, okay, at this point of time horizontal velocity is Vx, whatever Vy, Vi, okay, so that's it. Okay, and time is 0 to 2 seconds is taking, but let's take t because we have to get the integration. We have to go in the x, right? From velocity again we will write down the expression and then again we will integrate. So that's why you have to write down here. So here if we integrate, we can say ln of Vx by ux. Okay, limits you can put. I hope you know integration better than me. C by m and here t. Okay, so here Vx you can write down as what? Ux into e raised to power minus C by m into t. Okay. Shall we put the value of C and m? So if we put C 0.1, m is 0.2. You can put the value also. Otherwise you keep it as it is only. Let's keep it as it is. Okay. So from here ux is a constant, t is variable. So here you can write down this as dx by dt. Okay. And take dt that side and integrate. So dx you can say what? Integration of dx is equals to here, integration is what? Ux outside, integration of e raised to power minus C by m into t dt. Okay, x is changing from 0 to x value that you want to get, and here time is changing from 0 to 2 seconds. Let's check, because other than x, now we don't have to get, we have to get the x only, na? So put the value here 2. Okay, here what is this? X and ux. Integration we know, e raised to power minus C by m into t only will come 0 to 2 and divided by minus C by m. Okay, understood? So here m by c, m ux by c minus inside when you will keep 2 will come, so 0 limit will put later on, right? So minus 1 will come, so minus inside, so 1 minus it will become, right? This minus sign inside you send 1 minus e raised to power minus 2c by m. Okay, now put the values here. Okay, so x equal to m value 0.2, 0.2 ux we can say what u is given na 270. How much? 270. So this is 270. Okay, 270 cos 60 sin 30 1 by 2, 270 by 2. Okay, so this is 270 by 2. Okay, and c value is how much? C value is given as 0.1. 0.1. Okay, and inside what you have? 1 minus e to the power minus 2 into c value 0.1 divided by 0.2. Okay, so here e to the power minus 1 only remaining, right? And here also 0.2, this denominator got cancelled out. 0.1 into 2, 0.2. So that got cancelled out, 270 only remaining. So here you have x equal to 270, 1 minus e to the power minus 1. So here x equal to, he said na e ki value, if you want you can use 2.7. So 270 into e minus 1 by e, right? So x equal to how much? 270 into e minus 1, 2.7 minus 1, 1.7 divided by 2.7. Okay, dot cancel out, dot removed, right? 27, x equal to 170. So 170 meter, because everything was in SI unit. So 170 meter is your answer. So meter he is asking, 170 is your final answer. Got it? So solve in the horizontal direction, because in horizontal you have one force only. Okay, so in horizontal we can solve because we want the horizontal only. Why to go in mg sin theta and cv sin theta, right? Okay, because we want everything in horizontal only at the end. So why should I solve in the vertical? Okay, next 15th, 16th question. He mixed the Doppler effect and your, what we can say, actually it is SHM. Okay, but if you see here, he gave cos theta equal to 0.9, right? So cos theta equal to 0.9 he gave, means you don't have to, he is saying you that you use work energy theorem and then calculate. See how, we will see here. What he is saying is, like this you have theta naught. Okay. From here, I am taking little bit up so that you can understand. Theta naught, okay, coming here, okay, reaching some velocity v. Okay, so symmetrically, if you see here, audio transmitter T and receiver R is hanging vertically from two identical massless strings of a length 8 meter. Okay, length is given at 8 meter with their pivots well separated along the x-axis. Okay, they are pulled from the equilibrium position in opposite direction along the x-axis with a small. So equal pulled equilibrium position in opposite direction with cos theta equal to 0.9 both equally. Okay, and release simultaneously. If the natural frequency of transmitter is 660, okay, f naught is given 660 and the speed of the sound in air is 330 meter. Okay, so c also given, speed of sound. Okay, maximum variation of the frequency as measured by the receiver. Okay, so if you understand maximum variation, okay, when will happen? Maximum variation, so like minima, there will be many. When he is here like this, he is also released and he will reach the, at the same time he will reach here. Okay, actually I can draw it equally. He will also reach here with same velocity because he is released at the same angle theta naught. Okay, from here, right? That we can say. Now, when they are coming, the receiver, observer and receiver, whichever you want to consider receiver, observer, doesn't matter. When they are coming towards each other, both are towards each other, right? So Doppler effect I gave you, easy method to remember. Okay, and both are coming towards each other, so frequency will increase, right? So you will hear a maxima. When they will reach here, stop and then coming back. So now they are going away. Okay, so at that point of time you will hear a minima. So both are, this is this side, this is this side, right? Correct? So f, the maxima that you will hear, value of v will calculate. Hold on. Frequency maximum that you will hear, that what it will be. Let's consider c equal to, given to you, that value is 330, right? So I will keep it c as, right, as we keep in notes. Okay, so c, now observer want to increase, right? So observer plus v by c minus v into f naught. I hope I don't have to explain. numerator we write down the observer, okay, and denominator we write down the source, right? Sorry, I wrote the receiver, okay. So source or transmit from whatever, okay. So source, that is source, so source will come in denominator, so he will put a negative because he also want to, he is coming close to the observer, right? So he also want to increase, so negative will come. So this is F maximum. F minimum, what you will write down? You can say C minus V, because when he will go this direction and this, they will come like this and then they will come here to go opposite direction with the same speed only, V only, right? Work energy theorem we will apply. Obviously, you will get the same answer. C minus V by C plus V into F naught. These are the F maximum and F minimum you will hear, okay? Difference of this he is asking, if you read it, maximum variation, right? So variation he is asking, so calculate the delta F. So if you solve here, maximum variation C plus V whole square minus C minus V whole square by C square minus V square into F naught. This will come. You can take the LCM. You can subtract F max minus F minimum and take the LCM. Okay. This will come delta F. Here C square V square cancel out from this, and you will have 2CV, 2CV, 4CV. 4CV F naught by C square minus V square. Okay. Now let's calculate the V and then we will put the value. Okay. So here I can apply the work energy theorem. Okay. Work done by gravity. Mg, this H. H is how much? I can say Mg, H is nothing but L minus L cos theta. Okay. So L common. Okay. So you can say MgL 1 minus cos theta, and cos theta value is also given. Okay. Let's write down in next step. Okay. This work done is equal to change in kinetic energy, final kinetic. Only one you write down, same everything. Okay. Half M V square. Okay. This is your kinetic energy. M got cancelled out to this side. So V is nothing but under root of 2GL 1 minus cos theta. Okay. Now let's put the value. V is equals to under root of 2G. G is, he told 10 only, na? G he said 10 into length. I think length is given where 8 meter. Okay. 8 into 1 minus cos theta is given as 0.9. So 1 minus 0.9, 0.1. Okay. So 10.1 cancel out, 8 to the 16, 4. This came 4 meter per second. Okay. V came 4 meter per second, put it here. So I can say delta F is nothing but 4CV, I think. Why I switched this? 4CV F naught by C square minus V square. Okay. 4C is 330, correct? C is 330 here. Into V, just we calculated 4 into F naught, we have 660. Okay, divided by C square, that is 330 square minus 4 square. Okay. Now understand one thing. Delta F. If you do the comparison directly, okay, that comparison to 330 square, the 416 is very low, right? So if you ignore this, this is 330 square, right? So 330 square, 330 cancel out, and 1 330 cancel out here, 2 will be remaining. 4 into 4 into 2, okay? So that is 16 into 32, okay? I have calculated that if you don't ignore this, okay, you can calculate this. If you don't ignore this and you calculate, your answer comes 32.001 or 4, I think. Okay. If you don't ignore it, exactly calculate. How you will calculate? In denominator, you can write down 326 into a square minus b square, na? A plus b, a minus b, right? 326 and 334, like that. Okay, and use the calculator, you can calculate. This will come. So better if you ignore here and you will get a 32 answer. Okay. If you don't ignore, you will get this, but as per the 2 decimal, you can say 0.00 only is coming. So 32 we will answer. Okay. So 32 is the answer of this question. Okay. I hope this is clear. Okay. You selectively, if you do, like this question was very easy. Okay. Easier side. Okay. This question, or this question, if you see, if you understand this horizontal direction thing, then it is a little bit easier side. This kind of question we have done in notes, okay? So I hope this was doable. Many questions are done. This was easier side because he gave it thermal conductive only, right? So I hope like that's selectively question, if you understand, then it is selectively only. Obviously you have to do that, you have to select in the exam. So I hope your JEE Advanced have went well and you secure a rank. Okay, thank you, have a nice day.